Swayam Prabha. Digital India. Educated India.
Hello everyone. So, now we will do some numerical based on ring frame. So, some simple numerical we try to understand the process. Okay. Now, the first numerical it is very simple one, the delivery rate of ring spinning machine. So, this is the delivery rate here V d, delivery rate of ring spinning machine producing 25 any yarn is 15 meter per minute. If the spindle speed is 15,000 rpm, what will be the Tm of yarn? So, twist multiplier. So, we know the twist multiplier equal to Tpi under root Ne. Okay. Now, we have to calculate the twist per inch. So, given data, delivery speed is given and yarn count and spindle speed is given. So, Tm is asked. So, twist per meter we can calculate. So, spindle speed by delivery speed. So, it is 1000 twist per meter, and from this we have to convert it to twist per inch. So, twist per inch it is divided by 39.37, which is the factor from inch to meter. So, meter to inch. So, twist per inch will be 25.4 twist per inch, okay. And then we can calculate the twist per twist multiplier. So, from this it is very simple one, it will be 5.08 is the twist multiplier. Next, the final yarn count required in the ring frame is 40 with 26 TPI. Now, if the twist contraction in spinning is 2.7%, if the feet of roving count here it is a 1.6 Ne, and draft, what should be the draft? Now, what is given here? So, given data, yarn count 40 is Ne, twist per inch is 26. So, from there the twist contraction is 2.7% and feed roving hank is 1.6. Now, draft in ring frame should be actual draft. What should be the actual draft? 40 divided by 1.6. So, we should have 25 draft, actual draft, okay. But the ring frame draft should be, so 2.7% contraction. So, we should keep the ring frame draft little bit higher. So, 2.7% higher than the actual draft, because 2.7% contraction is there. So, 25 multiplied by 102 by 100. So, it will be 25.7. So, that should be the ring frame draft. We have to mechanical draft we have to keep in the ring frame. Next one. So, draft in the ring frame is 25.7. So, next one, the ring frame machine having ring diameter 1.5 inch. The traveler speed is 20,000 rpm, traveler rpm. The count produced in the machine is 40 English count. So, what will be the traveler surface speed in the machine? So, traveler surface speed is basically traveler revolves around the ring. So, it moves around the ring. So, that will be its the rotational diameter will be 1 point, that revolution, that is traveler basically does not rotate, traveler revolves around the spindle. So, that speed is revolution speed is 20,000 rpm and with the diameter 1.5. So, we can calculate. So, ring diameter is 1.5 inch, that means 38 millimeter, and traveler speed is 20,000 rpm. So, count is not required because only traveler surface speed is asked. So, traveler surface speed will be pi dn, okay. D is the diameter of ring, pi dn divided by 60, okay, surface per second, traveler surface speed it is per second. So, that is why per 60. So, pi diameter is in, this is in millimeter. So, we convert it to meter, this is meter conversion, and n is the rpm and in second conversion. So, we will get the, this is the in meter per second. So, it will be 40 meters per second approximately. Next one. Now, as I have mentioned, the traveler does not rotate, it slides or revolves around the spindle. So, a traveler slides at 120 feet per second, the sliding speed is 120 feet per second on a ring of 1.75 inch, this is inch diameter. So, this is a ring with a diameter of 1.75 inch. The twist of the yarn being spun at a bobbin stage. So, what we are trying at bobbin stage. So, at bobbin stage twist will be from our earlier discussion Nt by delivery speed. At bobbin stage is 20 TPI. So, this is 20 TPI and it wounds on the 1.5 inch diameter of the bobbin. So, diameter of bobbin at that point is 1.25 inch. So, what we have to calculate? We have to calculate the spindle speed. Okay. Here delivery speed is not given, only traveler sliding speed is given. So, RPM of traveler, that is RPM of the revolution of the traveler Nt, and ring diameter, because as it is in feet per second. So, we are converting it to feet per feet. So, ring diameter is 1.75 by 12 feet. So, pi D and N. Okay. So, that is actually the sliding speed of traveler per minute. Okay. This is per traveler in, that is in feet per minute. So, feet per second is given sliding speed. So, it will be 120 multiplied by 60. So, here only unknown factor is N t. So, we can calculate the traveler RPM at that point, at the speed of the, at the diameter of the bobbin 1.25 diameter, 1.25 the bobbin diameter, the traveler sliding speed is, so traveler RPM is 15,750. So, 15,715 RPM of traveler. Now, what we have to calculate the spindle speed. So, spindle speed we can calculate. So, spindle speed is Ns RPM. So, twist per unit length at the bobbin stage is the Nt by Vd. So, from there we can calculate the delivery rate. So, twist is known. So, in twist is there. So, we can calculate the delivery speed. Twist is given here as in the 20 TPI is already given. So, from there we can calculate the delivery rate. Delivery rate is Nt we have calculated, that is traveler RPM we have calculated 15,750 and 20 is the TPI. So, delivery rate is 785.75 inch, that is the delivery rate, and the bobbin diameter was given. So, bobbin diameter at that point is 1.25 inch. So, pi 1.25 Ns minus Nt, Nt at that speed was given, at that diameter was 15,715, and this is the delivery rate which is fixed. So, Nt minus Ns we have calculated, this is 200. So, 785.75 divided by pi multiplied by the bobbin diameter at that time. So, Ns minus Nt is 200, that means the traveler speed is little 200 RPM lower than the spindle speed at that bobbin diameter. So, spindle speed is calculated. So, traveler speed was already calculated earlier. So, we can get the spindle speed 15,915 RPM. So, here the main issue is that we have got the twist per unit length at the bobbin stage. So, that we have assumed, we have taken Nt by Vd. Next one, a traveler slides at 120 feet per second speed at 1.25 inch bobbin diameter on a 1.75 inch ring diameter. The data in the first line are exactly same to that of earlier one. The 20 takes 100% cotton yarn is being spun from one any roving. Okay. What is the spindle speed? Now, the conditions are given, a full roving package of 1.5 kg, that is mass of roving, that the net mass of the roving, exhaust in 70 hours of continuous running of the ring frame. So, there is no stoppage. So, 70 hours of continuous running, one full roving package of say 1.5 kg in 70 hours, it gets exhausted. Okay. Assume there is no visible loss and ring frame is running at 100% efficiency. Now, try to see. So, 1.5 kg of roving of one NE. So, that means we can calculate the length of the roving. So, this is the package size. So, traveler RPM is NT, ring diameter is given, and from there we can calculate the traveler RPM, because sliding speed is given. So, traveler RPM will be same as the earlier one, last numerical 15,715 RPM, and the delivery speed will be, so a delivery speed is S d meter per minute, the ring frame delivery speed. Now, that we have to calculate if we want to calculate the NT. So, delivery speed is not given. Now, try to calculate. So, total draft in ring frame, so will be, so takes of yarn 20 takes. So, NE it will be 29.52 NE, and the roving was 1.0 NE, and yarn we are getting it is a 29.52 NE. So, total draft will be 29.52 in the ring frame. So, roving take up speed is SI, okay, and the total length of roving in the full package is L, that we can calculate from the total mass and the roving count. So, roving count is 1. So, length in yard by weight in gram multiplied by 0.54, this is from the conversion formula we get. So, we know the weight in gram. So, we can calculate the length in yard L. So, length in yard. So, from length in yard, this is the length in, just conversion from length in yard to length in meter. Okay. From there we can calculate the length in meter. So, L is the length in meter, okay, multiplied by 1.0936 will be length in yard. So, we can calculate the total length of the roving package is length of the roving in a package is 2540 meter. This total length is exhausted in 70 hours of running. So, we can calculate the speed SI, that is roving take up speed we can calculate. So, what is the roving take up speed? L is given and it is in 70 hours. So, 70 hours, the roving take up speed will be 0.6 meter per minute. SI will be 0.6 meter per minute, and that is input, and delivery speed, as we have assumed there is no fiber loss and no slippage, if we assume. So, 29.52 0.52 times, that is draft times of the take up speed. So, delivery speed will be 17.71. So, 0.6 multiplied by 29.59, that is the delivery. So, VD is there or SD, and we know from the earlier relationship, so SD is known and NT is also calculated. So, from there we can calculate the spindle speed as 15,892 rpm. Now, next numerical. The traveler sliding speed is 40 meter per second when the bobbin diameter becomes 30 millimeter. What is the ring diameter? So, ring diameter has to be calculated. Now, the data which is given, the full roving package 1.5 kg net mass, exhaust 70 hours of continuous running, that is already we have done in the last numerical. Roving hank is 1 NE, brake draft is given here, brake draft is given as 1.15. Assume there is no invisible loss, no twist contraction, the ring frame is running at 100% efficiency. The 3 roller drafting system, double apron drafting system, the twist per inch and twist multiplier are 25.16 is twist per inch and twist multiplier is 4.63. Now, we have to calculate the ring diameter. So, now roving count is given 1, roving mass is 1500 gram, length of roving was calculated earlier also in last numerical also 2540, and input speed of the roving is 0.605 meter per minute. TPI is given. So, TPI, so NE we can calculate the TPI is 25.16 and TM is given. From the TPI and TM we can calculate the English count. So, English count of yarn is calculated and draft of the roving frame is calculated and output speed. So, draft is given. So, input speed was 0.6, so draft is calculated like earlier numerical, it has become 17.86 meter per minute. So, it is a delivery speed. So, TPI is NS spindle speed by delivery speed. So, this is the delivery speed in meter per minute and in inch it will be 13 divided by 39.37. So, this is the conversion between meter and inch. So, TPI is calculated. From there we can calculate the spindle speed. Okay. So, spindle speed. So, TPI is given. So, TPI is 25.16, delivery speed is 17.86 and the 39.37. So, we can calculate the spindle speed. So, this spindle speed is calculated and now from there we can calculate the traveler RPM. So, this is the traveler RPM is NS. So, from there we can calculate spindle speed is given. So, we can calculate the traveler RPM as 17,501.5, that is the traveler RPM is given and traveler sliding speed also given, okay. That is the 40 meters per minute. 40, what is the traveler surface speed, sliding speed is 40 meters per second. So, 40 meters per second we can come back here. So, traveler RPM. So, traveler surface speed will be pi dr is in millimeter n t, pi dr n t is the diameter of the ring and n t is the traveler RPM. So, pi dr n t is the traveler surface speed, which is equal to 40 meter per second, that means 40,000 multiplied by 60, that is meter per millimeter per minute. So, from this equation we can calculate easily the ring diameter. Ring diameter here is effectively 43.65 millimeter. Next numerical. A traveler slides at 120 feet per second speed at 1.25 inch bobbin diameter on a 40 millimeter ring diameter. Okay. So, bobbin diameter is given in inch, ring diameter is in millimeter. What is the spindle RPM? So, similar data is given here, full roving bobbin of 1.5 kg, okay, net mass, exhaust in 70 hours of continuous running, roving hank 1 and brake draft 1.15. Assume all these data are given and the main zone draft is here given. So, brake draft is given 1.15 and main zone draft 25.67. The total draft will be 25.67 multiplied by 1.15 is the total draft. So, here total draft can be calculated and the numerical will be similar to earlier one. So, diameter of ring is given 44 millimeters, 1.73 inch, we are trying to convert into inch. So, the total draft is 29.52 in the ring frame. So, yarn count is 29.52 because the roving package was 1 new NE. So, total draft in ring frame is 29.52. So, ring frame take up speed is SI. So, total length in the package is equal to L. So, roving count, length of yarn and weight in gram. So, from the similar way we have already done. So, we get the roving length 2540, it is a similar same data which was used in earlier numerical. Now, SI is 0.6, again the same data we have used, just to we are trying to understand the concept. So, in meter per minute, so S delivery speed will be 17.71 meter per minute and pi bobbin diameter in inch. So, we are converting into meter. So, NB minus NT, bobbin speed minus traveler speed, bobbin speed means spindle speed. So, here the spindle speed, same spindle speed is this one, okay, plus here traveler speed plus the total this all this factor. So, we get the spindle speed as 15,892. So, next numerical is the 100% production on a ring frame producing 20 NE yarn at 20 meters per minute is 100% production, that is gram per spindle per hour. So, it will be simple one. So, count produce 20 NE, okay, delivery rate 20 meter per minute. So, production per hour will be 1200 meter per machine per spindle. So, production rate gram per spindle per hour. So, this is 1200 meter, okay. And here this is in hank we are doing, that is in by divided by 20, and here it is a we are getting as the from pound to, this is in pound, from pound to kg we are getting, and from there we are getting it is in gram. Okay. So, you can see here how the conversion is taking place. So, here one this is in 1200, this is in meter to yard we are dividing by 0.916, then from yard to hank we are dividing by 840, and we are to pound, okay, when we are dividing by the yarn count, okay. And then to kg we are getting the production at 35.36 gram per spindle per hour. On ring frame the spindle speed is 20,000 rpm, the yarn twist after cone winding is 10. That means, the cone after cone winding means we will be taking as ns by Vd equal to 20 after cone winding twist per centimeter, traveler rpm at the winding circumference of 5 centimeter. So, that is the winding circumference, not the diameter we are talking about. So, we have to calculate the diameter of the bobbin at that point. So, 20 spindle speed is 20,000. So, twist per inch is 25.4 twist per inch. So, winding circumference is 1.97 inch, that is 5 centimeter. So, what is the, we have to calculate the traveler rpm. So, front roller delivery speed is that spindle speed by TPI. So, TPI was given 25.4. So, 787.4 inch per minute. The lag between the spindle and traveler, that is equal to that winding rpm, delivery speed by winding on circumference, that is pi d. So, that is a lag and winding on circumference pi d, they are given. That is the lag front roller speed divided by front roller delivery speed, spindle speed by, this is front roller delivery speed divided by the TPI. So, winding on circumference, delivery speed by winding on circumference is given. So, we are getting the RPM lag is 400 RPM. So, spindle speed is 20,000 RPM. So, traveler speed will be 20,000 minus 400. So, it will be 19,600 RPM. Now, next one is that on ring frame, the ring frame is running at 14,000 RPM, is producing a yarn of 15 meter per minute speed. the difference in yarn twist, that is turn per meter in the yarn at bobbin stage, when the package diameter is changes from 20 millimeter to 40 millimeter. So, at bobbin stage the twist will be NT by VD, that we should remember. Now, let us do it. Spindle speed is given and delivery speed is given here. So, 14,000 and 15 meter per minute, and finds the twist difference when bobbin diameter is from 20 to 40 at the bobbin stage. So, speed lag between spindle and traveler at 20 millimeter diameter will be getting 238.85 rpm. So, that we have already seen here. So, delivery speed by circumference of bobbin. This is the lag, okay, and delivery by circumference. From there we are getting, and traveler speed is the spindle speed minus lag. So, this is the traveler speed here. At this point, when the diameter of the bobbin is 20 millimeter, the traveler speed is 13761.15, and actual TPM at bobbin stage when the diameter is 20 millimeter will be traveler speed by delivery speed. So, it will be 917.41 twist per meter. Similarly, for 40 millimeter diameter we can get the spinning lag is 119.43 rpm. So, traveler speed will be 13881, 13,881 rpm, and actual twist per meter will be 925.4. So, there will be difference in twist per meter is 8. So, that is the answer. Okay. Now, another numerical, it is related to angle of lead and yarn tension. So, the permissible minimum angle of lead of yarn pull is that is angle of yarn pull is 28 degree. For a ring diameter of 40 millimeter, what is the recommended minimum bobbin diameter? So, angle of yarn pull is theta, and sin theta will be bobbin diameter by ring diameter. Ring diameter is given, and sin theta minimum angle of lead is 28. So, bobbin diameter, the minimum bobbin diameter will be sin theta sin 28 multiplied by 40, it will be 18.78 millimeter. So, if we try to use the bobbin diameter less than that, that means there will be a huge yarn tension. So, yarn we will not be able to spin the yarn. So, last numerical, the recommended range of angle of lead is given 28 degree to 367 degree. For a ring of 40 millimeter diameter, what will be the appropriate bare bobbin and full bobbin diameter? So, what will be the bare bobbin and full bobbin diameter range? So, the same way we can calculate angle of pull for the bare bobbin, it will be used 28 degree. So, ring diameter is there. So, sin theta equal to bobbin diameter by ring diameter. So, for 28 degree the bobbin diameter will be the bare bobbin diameter, that is a empty bobbin diameter. So, bare bobbin diameter will be 40 ring diameter multiplied by sin 28. So, it will be 18.78 and it can go up to the full bobbin where the angle of lead will be 67. So, it is 36.82. So, if we go beyond that, there will be beyond 67 degree, there will be two problems. One problem will be the yarn tension will be too low, so that balloon collapse may take place, and second one will be there will be very low gap between the ring and the bobbin. So, that it may disturb the traveller movement. So, we have come to the end of the numerical. We have tried to understand few numericals, we can do many numericals. So, just to understand the process and how the angle of lead and how the twist relationship, that is at the package form, what is the twist relationship at the after unwinding in the cone, what is the relationship. Now, before that let us do on another example. The permissible minimum angle of lead is 30 degree, similar numerical, and for ring of 40 millimeter diameter, the minimum bobbin diameter will be the same we have done already. This is angle of lead, the minimum angle of lead 30 ring diameter, and bobbin diameter will be, there is ring sin theta is bobbin diameter by ring diameter. So, bobbin diameter sin 30 degree multiplied by 40. So, it will be 20 millimeter. So, minimum 20 millimeter bobbin diameter has to be used. So, we will stop here. Thank you.